All right, class, welcome to this lecture on the equilibria of slightly soluble salts, part 3. All right, class, so in this video, we're going to be looking at predicting the solubility of a salt in acid. Okay, predicting solubility in acid. An ionic compound that is insoluble in water might be soluble in acid. It will be soluble if adding acid causes the equilibrium to shift to the right. Okay, so for example, if we were considering the salt aluminum hydroxide has this formula. We write the equation with the solid on the left, as we've talked about, in equilibrium with its ions. Okay, the ions are shown on the right. All right, now let's imagine, class, that we add some hydrochloric acid. Now remember, hydrochloric acid is a strong acid, so that's really like you're adding hydronium and chloride. Okay, since this is a strong acid, remember, when you take a strong acid and put it in water, in this case, what? HCl in water, all of the HCl reacts, and you end up with this and this. So when we say, add some hydrochloric acid, we're really adding both of these ions, okay? What's that going to do? Okay, well, the hydronium ion is going to react with the hydroxide. It won't react with the aluminum ion, it will react with the hydroxide. And when it does that, it forms water, okay? So the added hydronium reacts with the hydroxide and it lowers the concentration of the hydroxide. If we have this equilibrium and we add an acid and that acid reacts with this, what's happening to this? It's being used up, right? So what happens if the concentration of the hydroxide is lowered? The equilibrium is going to shift to the right. If this is removed, how is this being removed? Well, it's reacting with the hydronium. So if that is being removed, the equilibrium is going to shift to the right, and the solubility of this salt increases. Adding acid actually causes this to go into solution. Okay. What about calcium carbonate? What if we had calcium carbonate? Well, let's look at it. You write the equation. We've got calcium carbonate, an equilibrium of that solid with its ions in solution. Okay, let's take the same scenario. Let's say we add some hydronium. Okay, will hydronium react with calcium or carbonate? It will. Which one? Is hydronium going to react with calcium? No. But it will react with this, won't it? What is this, class? This is a base, isn't it? Isn't that a base? Okay, it's a weak base. So, yes, the hydronium will react with the carbonate ion. It donates a proton. We get bicarbonate, we get water. Okay? Weak acids form readily in water. This reaction does proceed. This is a weak acid. Weak acids form readily in water. So, the added hydronium reacts with the carbonate. So as a result, what happens to the concentration of the carbonate? It goes down. Okay? This is essentially being removed from the solution when we add hydronium because the hydronium reacts with it. The more hydronium we add, the more of this reacts. This concentration is lowered. What's going to happen to the equilibrium, class, if we lower the concentration of the carbonate ion? It's going to shift to the right. And the solubility, if this shifts to the right, more of this dissolves. The solubility of the calcium carbonate increases. Okay? So adding an acid to this salt it will cause it to dissolve. It increases the solubility of that salt. What about silver chloride? Let's look at that. Okay, so silver chloride, we show the equilibrium equation here. Let's take the same scenario, class. Let's add some hydronium. Will hydronium react with silver ions or with chloride ions? What do you think? No. Hydronium will not react with silver ions. It will not react with chloride ions. You say, well, why not? This reaction does not occur, class. This reaction does not occur. What kind of acid is this? Is that a strong acid or a weak acid? You know the answer to that. That's a strong acid, right? The stronger the acid, the what? The weaker the conjugate base. This base is so weak, it will not react. Will not react. Class, strong acids do not form in water. Strong acids do not form in water. Okay, they do not. This reaction does not occur. Okay, so adding hydronium does not cause the equilibrium to shift. If this equilibrium doesn't shift, what does that mean? The solubility of this is not affected. You can add hydrochloric acid to this all day long, class. It's not going to cause any of this to go into solution. Okay? So we've looked at 3 examples, class, of salts to which we have added acid. Now, is there a way that we, in kind of an easy way, we can predict whether or not a salt that is insoluble in water, if that salt will be soluble in acid? There is. There is a way we can predict. What you want to draw your focus to is the anion of the salt. And ask yourself, will the anion react with hydronium? Okay, that's the question. So let's go back. We're going to look at each of those 3 salts that we had. Aluminum hydroxide. What do we want to focus on? We want to focus on the hydroxide, and we want to say, will this reaction occur? Will hydronium react with hydroxide? It will. It will. This reaction occurs. Okay? So what does that mean? This will be soluble in acid. Okay? This will dissolve in acid because hydronium reacts with this anion. Okay? Calcium carbonate. Okay? If we're trying to predict, will this dissolve in acid? It won't dissolve in water. Will it dissolve in acid? Well, we ask ourselves, will this anion react with hydronium? It will. It certainly will. Okay? So what does that mean? That means that this salt is soluble in acid. Okay? Class, this is a weak acid. Weak acids form readily in water. This is a weak acid, isn't it? It's not a strong acid. This is a weak acid. Weak acids will form in water. They do. Okay? Silver chloride. Okay? If we want to ask ourselves, will this dissolve in acid? It won't dissolve in water. Will it dissolve in acid? Well, we want to ask ourselves, will this anion react with hydronium? No. Why not? What kind of acid is that? That's a strong acid. Class, strong acids don't form in water. If this reaction does not occur, you know what? This will not dissolve in acid. Okay? This will not dissolve in acid. So this is the key point to remember, class. Strong acids do not form in water. Strong acids do not form in water, but weak acids form readily, easily in water. So if the anion is the anion of a weak acid, the salt will be soluble in acid. Let me repeat that. If the anion is the anion of a weak acid, the salt will dissolve in the acid. Okay? All right, so let's look at the effect of pH on solubility. Really, we've been doing that in the past few slides when we talk about adding acid, right? We're changing pH, but let's just kind of summarize some of what we've talked about here. The pH affects the solubility of some salts, doesn't it? Okay. If the equilibrium is shifted, the solubility is affected. So let's consider aluminum hydroxide. Okay, so this is the reaction for aluminum hydroxide, the equilibrium, right, that we have for a saturated solution of aluminum hydroxide. The higher the pH, the greater is the concentration of hydroxide. Okay. Aluminum hydroxide is going to be less soluble at higher pHs. Okay. How do you increase the pH? You add a base, don't you? So if sodium hydroxide, for example, is added, the hydroxide ion concentration increases. The equilibrium will shift to the left. If we increase the pH, we can do that by adding hydroxide. If we increase the concentration of hydroxide, that shifts the equilibrium to the left. And less of this will dissolve. It's less soluble at higher pHs. Okay. The lower the pH, the greater is the concentration of hydronium. Okay. Aluminum hydroxide is more soluble at lower pHs. How do you lower the pH? You add an acid. If hydronium is added, the hydroxide decreases. Okay. If hydronium is added, the hydroxide decreases. Why? Because the hydronium reacts with that, doesn't it? Okay. The equilibrium will shift to the right. If this concentration decreases, Le Chatelier's principle says that the equilibrium will shift to the right. If the equilibrium shifts to the right, more of this dissolves. It is more soluble. The solubility increases. Okay? Now, if hydronium is added, hydroxide decreases. Why is that? Well, remember this, class. Remember this. This holds for all aqueous solutions, doesn't it? The hydronium times the hydroxide is a constant. Okay? If one increases, the other decreases. If this goes up, this goes down. If this goes down, this goes up. So if we add acid, what does that do? That increases the concentration of hydronium. If this goes up, this has to go down. What happens if we decrease the concentration of hydroxide? The equilibrium shifts to the right, and more of the salt will be soluble. So class, when you are adjusting the pH, you know what you're doing? You're adjusting this. When you increase the pH, this gets larger, and the equilibrium shifts to the left. When you decrease the pH, this gets smaller. The concentration goes down and it shifts to the right. Okay? So class, I hope that you have found this video lecture to be helpful in your understanding of how to predict whether salts that are insoluble in water, if those salts will be soluble when we add acid.